Okay, a couple things I'd like to go over. As you notice on this back page, this middle bottom one, I crossed that one off. That's also on the front page. That's also not how I want that to look. So left column, third one down. Okay. Left column, third one down where it says C3H6O.
Just write C3H4O.
We don't want that on both sides. So left column, third one down. Okay. I want you to do this molecule, CH2CO2. Okay. And then
Why isn't that? Can you rewrite that as like C2H2O2?
well, you all right. You can do C2H2O2. You can do that. That's fine. All right.
Where would you start it now?
Okay. So looking at this, and you go through your how you would perhaps approach that, which element do you think you would start with? Okay, so upon doing that, let's say you tried that and you did a single bond, because that's maybe how you would start it. And then you want to make a single bond with another carbon, or maybe you want to put the oxygen in there, but I would suggest you get rid of your carbons first. Then you can see what you have left. So there's our two carbons. So we can get rid of two hydrogens, one there, one there, and it looks to me like a single bond just does not work. Okay? Well, if that doesn't work, well then you try a double bond. And the best way to approach these is just a lot of trial and error more than anything else. So we put a dot there, maybe a dot here. Let's try our hydrogens again. Okay, we still had a couple X's left. Then you might say, well, we're getting closer, because we could put an oxygen here. And then we're out.
You just move the one on the top of the carbon.
Do what with the carbon?
Just move the one on the top of the, move that to where the O is. And then put the other triangle for the O on the right side.
This over here?
Yeah, and then put that X where that was.
Okay. Then when we look at this, this carbon's got 2, 4, 6, 8. This carbon's got 2, 4, 6. This oxygen has 8. So that just doesn't quite do it. Right idea, okay? Because that's maybe how you would want to approach it. So then finally, if that of a double bond is not working, well then we try the triple bond. Okay. And then if you prefer to do this, by this time we know what you mean when you do that. Because what you're showing is dot, 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 X, X, X. Those are your electrons. And that's fine if you just do dash, dash, dash. So one more dot here, one more X there. Okay. Well, let's go ahead and get rid of one of our hydrogens. Let's try that first. Okay. Then carbons are done, hydrogens are done. Let's go ahead and try an oxygen then. And it looks like that works. Would you agree?
Don't you need another hydrogen and another
Right.
Yeah.
And right here. I agree.
And you still got one more oxygen.
write the wrong formula? Oh, I just approached it in the wrong manner. That's all. Okay, so what we need to do on the left side is what we did on the right side.
Oh, I see.
Then we just need to attach an oxygen. There we go. Okay, now we got them all accounted for. I'm sorry, could you read? So that is how you would perhaps approach that problem. And when you get to the back side, for, I want to say it's C2NH3, I think there's actually 3 different ways you can look at that one. And go from there. And we probably could have done that C3H6O, but we crossed it off already anyway. Yep, we could have done that, but we crossed it out already anyway. Any questions on that front side? Even N2O2, there's 2 different ways you could do that one as well. And it says covalent and ionic bonding, but really the only ionic bond that I see on there is Li3PO4. So when you're looking at that one, what we would say, as you look at that formula, you would perhaps pick the element that has the least numbers of atoms in it. So if we see Li3PO4, just like that molecule of sulfuric acid or phosphoric acid, any one of those. Do we remember what it said in the video that what makes an acid be categorized as an acid? And you might not know what it was unless you're listening for it. Well, it's what causes the pH level. That's true. And it has to do with the hydrogens. If hydrogens get donated, then that's categorized as an acid. So when you look at this, we don't have carbon, we don't have nitrogen, so we pick the element that has the least number of atoms in it, so we would look at phosphorus. Okay? And phosphorus is in which column? Okay? So then what we see here is now we branch out with our oxygens. Okay? We can put one here. Then once you get this one, the rest of them will fall right in place because once you put an oxygen down here, being in column 6, it's missing one. This one would be missing one. This one would be missing one. But what element have we not talked about yet?
Lithium.
The lithium, which is in column what? So that's where that extra electron would come from. We'll just do an E, I guess. And that is how the molecule looks. And I know some students are going to do something like this, and I don't know, they're going to create a bond here. Oops, triangle, triangle. That should be a triangle, triangle. 4, 5, 6. Then they're going to put another oxygen here, and then another oxygen. I understand you're getting the octet rule to work out. And maybe we should say at this level that this works out. You got the octet rule to work. But I guarantee you that type of mentality, the next level you take that in college is just going to say, where did you learn that from? Okay? So we just want you to draw this, how the molecule actually looks. This way, not that.
What about, okay, so you have HONO
Yeah,
on this, and then you have
Rochester.
NO2H.
So you have two of the same compounds on that front side. But you just try with single bonds. If that doesn't work, then you move to double bonds. And if that doesn't work, maybe you have to do a triple bond. Okay, I'll go ahead and collect your papers. Make sure your names are on them. We will catch up to you next time.